Hello, students. I'm sure you all love to play with cubes. But let's understand this cube is made up of atoms. In fact, every object is made up of atoms, and an atom is comprised of protons, neutrons in the nucleus, and the electrons moving around them. Well, the question for you today is it possible to transfer electrons from one object to another physically, not chemically? Okay, let me show you something. Do you recall this experiment? When you rub the balloon against your hair, what happens? Yes, I'm sure you remember the chapter static electricity. So, when two bodies are rubbed, they get charged. You can see the electrons from the hair have got transferred to the balloon. Thereby, the balloon has become negatively charged because of gain of electrons, and the hair is positively charged because of deficit of electrons. It has nothing to do with protons. Similarly, when a glass rod is rubbed against a silk cloth, the silk is negatively charged and glass gets positively charged because the electrons from the glass rod have moved on to the silk cloth. So, the objective of this class is to understand the concept of charge. There are two kinds of charges, positive, negative. We all know like charges repel and unlike charges attract. Well, with the same charged balloon is brought near small bits of tissue paper. I'm sure you remember the experiment. Let's observe. Beautifully, the bits of paper get attracted to the charged balloon. But is it that the paper was charged? No. The paper had equal number of electrons and protons in its atoms. It's not a charged paper. But when the charged balloon came closer to the paper, the electrons in the atoms on the surface of the paper got rearranged. They moved away because we know like charges repel. So, in this manner, the paper got attracted to the balloon. Well, let's know more about charge. How is charge represented? We know force is represented by the letter F, work is represented by the letter W. So, charge is represented by the letter, sorry, charge is denoted by the symbol Q or small q. You may wonder why. Yes, because charge was once upon a time known as quantity of electricity. And if it is a quantity, it needs to be measured. So, coulomb is the unit of charge. Let's understand what is the charge on one proton and charge on one electron. So, you can see the charges magnitude is the same, but they carry opposite charges. So, let's understand now how do we find out the charge on the balloon. This balloon has 6 electrons extra. It's given by the formula Q is equal to plus or minus NE, where N stands for the number of electrons which are extra. So thereby it will be 6 into the charge of 1 electron. Thereby the answer is minus 9.6 into 10 raised to minus 19 coulombs. Let's say if I have a glass rod and let me put one more plus sign here, which means there are 6 electrons deficit. Remember, positive charge does not mean there are 6 protons. It means 6 electrons are deficit. So the charge on the glass rod will be positive 9.6 into 10 raised to minus 19 coulombs. So this is the first formula of the chapter. Smaller units of coulombs will be millicoulomb, microcoulomb, and nanocoulomb. Now you can remember what was the charge on one electron? 1.6 into 10 raised to minus 19. It's not milli, not micro, not nano. It's very, very minute charge on an electron. Right? So let's know if this much amount of coulomb is carried by one electron. So then one coulomb, one complete coulomb will carry how many electrons? Yes, that will be nearly 6.25 into 10 raised to 18 coulombs will be equal to 6.25 into 10 raised to 18 electrons will be present in 1 coulomb. Now we know that in insulator, plastic rod, these charges are static. They don't move, they're just there. Whereas in a metal or a conductor, these charges are in motion. So we'll understand more about charges in motion in the next session. Till then, thank you.